Skylab starts in the dreams of the people who wanted to go into space for a long time. Early in the 20th century, we saw people who were thinking about how do we get humanity off the planet Earth and into space.
There was a vision, a long-term vision humans had of exploring and going beyond, higher, farther, faster. There was the technical challenge, there was the scientific interest, there was the adventure, and there was just simply the demonstration of managerial and organizational and industrial economic competence in a world that was contested. So that was Skylab.
Throughout the 1960s, they looked at a number of different ways in which you could take the Apollo materials, particularly Saturn V and the Apollo spacecraft, and do space station-like things with them. So by the end of the 1960s, 1969, right after the successes on the landing on the moon, attention turns to the space station program, and Skylab is really born there, being the program for human spaceflight during the early 1970s, and to build our basis for experience, and to address those important questions that we had, which were, could humans physiologically adapt to long periods of space? Early 1973, we got ready to launch Skylab. The Skylab Saturn V is sitting on one launch pad. Of the two launch pads we had for the Apollo program, Skylab is sitting on one launch pad. Just a little ways away on the other launch pad is this Saturn I vehicle with the command and service module, because Skylab launches one day, and the vehicle with the first crew was supposed to launch the next day.
3, 2, 1, 0, and we have a liftoff. The Skylab lifting off the pad now, moving up.
Unfortunately, when Skylab, the laboratory, goes up, the micrometeoroid shield that was on it that also provided heat protection for the vehicle rolls back, jams into the solar arrays. That there are two big 5 kilowatt each solar arrays that we're supposed to deploy. Skylab gets in orbit, it's crippled. And we're in big trouble because Skylab needs that energy from those big solar arrays to operate and for the mission to be successful. And in 10 days, they quickly come up with a plan. We had people sew together a parasol sunshade that they could erect outside the station. They came up with some equipment that the crews could use to try and unstick the giant solar array that was stuck. And Pete Conrad and his crew, the first Skylab crew, go launch 10 days later and save the entire program. The $2.5 billion program would have gone down the drain if the crew hadn't gone up there and saved the mission.
Okay, we're free. We got 0.4 of a foot per second, Houston. Roger. Bye-bye, Skylab.
The story of the launch of the Skylab Orbital Workshop is one of those great triumphs of things going bad and engineers and humans and astronauts working together to fix them.
They have a very successful, almost month-long mission, and proved that, in fact, first, that the Skylab will work, that humans are really important to those things, and they get a lot of good scientific data. And of course, we had 2 more crews that launched later in the year. The second Skylab crew goes up for a longer period, and does lots of Earth science experiments, lots of solar observations. And then the third crew finally launches at the end of 1973 and early into 74. They're up for almost 3 months. And they observe, do solar observations, do more Earth observations. We do experiments with students. The first NASA student experiments go on during Skylab. The last crew leaves Skylab in early 1974. So a very successful program overall, despite the fact that it almost, on the first minute of operations, almost went in the drink.
One of the real triumphs of Skylab is that it basically took a situation gathering both the limits of what was possible and the possibilities presented by incredible technological developments, and put them together in a program that produced tremendous benefits in science, education, what spaceflight is all about. So it's a stepping stone. It was the stepping stone between the Apollo program and then later definitions of what spaceflight would mean for the United States.
Skylab is the first step. We learn how to operate in space. We build on that with the ISS. We now go on further beyond low Earth orbit to visit an asteroid and then onto Mars. That's the plan, and that's where we're going.